So before start the actual project explanation, I request you please subscribe my channel. So you can see on the screen up till now I have uploaded more than 66 video on Raspberry Pi. The Raspberry Pi with IoT, that is all this video. Then also IoT with Arduino, all this video are 26. And recently we started the new series on the PIC microcontroller. Before that I also cover the project on the Python web application. So if you want to learn Python, IoT, Raspberry Pi, Arduino, PIC from the scratch and from freely, then please subscribe my channel, please support me. And the most important part is whatever the code I have explained, whatever the project I have created on this YouTube channel, all these projects are freely available. You no need to pay anything for this project. So just if only point is you should watch complete video and you should follow my process. So if you want to learn something from the scratch and freely, then support me and please subscribe my channel and please click on like button. Hello friend, in today's session we will learn how we can interface a LCD 16 by 2 LCD with PIC microcontroller. So in this video we will see the importance of each and every line from the code. Also we will see how to interface this LCD in the Proteus software with the PIC microcontroller. So I request you please watch this complete video so that you will get idea about each and everything about this project. Okay, so first I will explain the next part. First we will see the output of this project so that you will get idea what you will learn from this video. So you can see once I start the project. So once I start the project, you can see on the LCD it is display here. This is the 16 by 2 video explanation program. So like this some message will be displayed on the LCD. So how to print that message on the LCD, that is user defined message on the LCD using PIC microcontroller, that we will learn in this video. So please watch this complete video. Now we will see how to interface this LCD. So first of all you require the Proteus 8.9 software in your laptop if you want my ready-made simulation, or if you have another software also then it's also okay, another version of Proteus then also it's okay. Only point is if you want my ready-made simulation then and then only you should use the Proteus 8.9. Otherwise you can follow my step whatever I am telling right now in your Proteus software, and with that also you can use any Proteus software for this project. So first of all you open your Proteus software with admission permission. So once I open my Proteus software, you can see you also find the new project. So just click on this new project. Once you click on new project, you can give any project name here, then your path wherever you want to save that project. Just click on this next button. Then after that select this create schematic from the selected template. Next button select this do not create a PCB layout. Next button, then select the no firmware project and click on next button and click on finish. So once you finish you will find the blank window here, and in this window we will try to create our schematic. So first of all you require the PIC 18F4550 IC. So just go to the component mode, then click on P here and type here PIC 18F4550. So this is my microcontroller, so I will use this microcontroller and place OK and OK here. So just I place my controller. So next part is we have to first connect this VPP pin to power supply. So just go to the terminal mode. Here you can see, sorry, just go to the terminal mode, then click on power. So once you click on power, just select that power here, place that power here, and then after that you can connect this pin, first number pin, to this power. So this is very basic step. Then after that we need to interface the LCD. So for next part is you require the LCD 16 by 2. So where you find the LCD 16 by 2, just go to the component mode, then click on P and type here 16 cross 2, 16x2. Then after that you can select any 16 by 2 LCD, click on OK and place that LCD here. Then after that you no need to do nothing. Then after that connect this RW pin first to the ground. So just go to terminal mode, click on ground and place that ground here and place like this. So I will tell you reason behind this why RW pin is connected to ground, because you can see RW means R/W. So R/W means read or write operation. So whenever we send the data on the LCD, we always require the write operation on that LCD. So to take the write operation on that LCD, we have to connect this LCD to the ground pins. That's why this RW pin is connected to ground, because Raspberry Pi always send to the signal to the LCD, so that LCD is nothing but the in write mode. So to connect to move that LCD into write mode, we have to connect RW pin to the ground. So this is very basic step of LCD. Then after that, what we have to do, RS pin, enable pin, then 8 pin we have to connect with the default pin. So just go to again component mode, click on default, place one default pin here, right click on default pin, rotate anti-clockwise, then place the default pin in front of RS like this, in front of RS. Then copy this default pin, copy to, right click on this default pin, then copy to clipboard, paste the another, right click, paste from clipboard, paste here. Then same you have to do 8 times, right click and just paste. So whatever the default pin I have taken, I just pasting one by one here, right click, paste. So one time you copied, no need to copy again, just right click and paste, right click, paste. So likewise we have placed all the default pin here. So this default pin nothing but what happen, I will tell you later. So first connect this RS pin to the this pin, RS pin, enable to enable, then 7 pin to 7, then here D0, D1, like this, all this pin you can connect one by one. So once you connect all the pins, first give the name of that pin. So first RS pin, so double click on this default pin and give your name RS, click on OK. Same enable pin, double click here, give a name enable, click on OK. Then D0, double click here, then give a name D0. Then same D1, double click on this pin D1, click on OK. Double click D2, D2. So like this you can give all the name with this above name. So D4, then D5, then D6, and then D7. And click on OK. So in this way we just completed the LCD connection part. We have to connect that LCD with the with the PIC microcontrollers. How to connect, I will tell you. Okay, once you connect this all the LCD pin, now next party we have to connect with the PIC microcontroller. So again we require one default pin. So just go to terminal mode, click on default, place one default pin in front of RD0. Right click on the default pin, rotate anti-clockwise. Then after that right click on the default pin, right click on this default pin, copy to clipboard, again right click, paste from clipboard like this. You have to paste again total number of pin. So all the pin you can see 1 2 3 4 5 6 7 8 9 10. So just 10 pin we require. So likewise copy and paste all the default pin like this, copy and paste, copy and paste, then copy and paste. So then after that you can connect this pin like this, one by one pin, all the pin you should connect like this, you can connect one by one pin. Then after that you have to connect all this pin with the PIC microcontroller. So basically this is the default pin. Now virtually we connected this pin to here. So first RD0 with D0. So same name, you can double click on this default pin, and after double click you can give same name, whatever the D0, same name should be reflected here. So D0, then D1. So like this all the names should be reflect as it is. D1, D2, then D3, then D4, then D5, then D6, then D7, then RS. Same name, you can see capital letter RS, here also capital letter RS, D7, RS, and then enable. So this default pin nothing but the connection of this pin with this pin virtually. So you can see virtually it is connected. So no need to draw, like this like this. So to make your circuit very easy and clean, you should use the default pin. So with this default pin, now we have connected all the pin with the PIC microcontroller. So now we will first verify this circuit. So that to verify this circuit you require hex file. I already have the hex file. So how to build that hex file we will see in this video also, but later part. first I will copy this X file. So how to create this one X file I will also tell you later, but first we will see this circuit is working or not. Click on OK. Yeah, now our circuit is working perfectly. That means whatever I showed you, whatever I shown you just now, how to connect LCD with PIC, it is working. Now we will see the programming part, and then we will see how to create hex file and load into your project. Now once you draw this circuit, if you want to give square box like this, you can see I have given the square box like this. So how to give the square box and name I will tell you. Just go to the square box, click on pin and draw the square box like this. After you draw the square box, if you want to give the name, just go to the A, click on pin and type the name like this LCD, and you can increase the size whatever you want size and click on bold, any like whatever the property you have to select, just click on OK and you can see. So again if you want to increase size, just go to the arrow, double click on this LCD and you can increase the size like this, click on OK. So in this way you can give the square box. Now we will see the programming part, but before start the programming part, it is very important. You should download my LCD PIC2 folder from my Google Drive link. I will provide this folder on Google Drive link and on Google Drive, and that Google Drive link you can find in the description. So in this folder, once you download, you will find all these files. So first you have to open this LCD PIC2 file, any LCD PIC2 file. So just double click here. So once you open LCD PIC2 file, so very important part is you require this MPLAB IDE software. Without this software, its program will not work. So how to install that MPLAB IDE software, that I already told in my first video of PIC Microcontroller. The video name is Proteus simulation of LED blink project. So in this project you will find how to install this software. Also you require the compiler. So for that you should watch that video, this video, and from that video you will understand how to install the software. So it is very important you should have this software in your end. Without this software your project will not work. Okay, then after that once we open the program, now we will see the importance of each and every line from the code. So first line is hash include PIC 18F4550. So basically whatever the PIC microcontroller we are using in our project, that is PIC 18F 4550. So same microcontroller header file we have to add here. Then some basic setting of microcontroller that is defined here. Then after that all these are the function: init LCD, init command, then init data, ms delay, send string. So all these are the function. We will see this function importance later. Then next part is hash define L data. L data nothing but the LCD data, that is port D. So you can see on with the help of this schematic, whatever the data pin of the LCD D0 to D7, that data pin we have connected to RD0 to RD7 of PIC microcontroller. So basically the data pin of LCD is connected to RD0 to RD7. So to define that port, which pin is connected to which which pin from the LCD is connected with the PIC microcontroller, that is defined here. So basically LCD data pin is connected to port D, that's why it is defined here. Then after that you can see enable RS pin, it is single pin. RS pin and enable pin is connected to RE0 and RE1. So as per the schematic you can see RS pin here, RS pin is connected to here, but this pin is nothing but the PIC RE0 pin. So that's why in the program we define here RS pin is connected to port E, RE0. Then after that enable is connected to port E, RE1. So same as per the circuit we have given this name here, enable pin is connected to RE1. So likewise whatever the connection we have given in the schematic, that defined here. Now the next part is void main. So void main is basically main loop in this PIC controller. So whatever the code inside this void main, it will run for infinite number of time. So first line is here in the void main string. So we have two strings, string 1, string 2. So in the string 1 you can see this is LCD 16 by 2. So this simple message, this is user defined message. You can edit this like this is Rahul also, or your name also, whatever the message you want to give you can define here in the 2 line, or you can use 3 line also, 4 line also. I will tell you how this will affect. So this is basically some message. So this in this message you can see here we have given the string as a array, string array. So why string array? Because in the C program we don't have the string data type. We have to collect all the character into one data type, and that is nothing but the array. So character string array, we are using array here. So which data type is character, and this is the way to define any string in the C language. So we have defined two string, that is two messages. Then after that you can see LCD init LCD function will be called. So this function we already define here. So this is the function definition, this is function calling, and this is the function body. So in the function body you can see once this function will be called, this line will be executed, and in this line you can see first line is trace D and trace C. So in the PIC microcontroller you can see there are many ports: RA port, RB port, RC port, RD port, RE port. So which port act as a which, for which purpose? You can see RA port act as a many purpose, RC port act as a many purpose. So for this LCD 16 by 2 program, we have to use any port as output port. To define that port as a output port, we are using this register TISD is equal to 00. That means all the pins on the port D act as the output. Why output? Because it will send the data from this port to LCD. So to define any port as output or input, we will use TRISD register, and TRISD00 means the output port. So TRISD is output, enable also output, because enable pin also connected with the this RE pin, that is E port pin also connected with the LCD, and this pin port should be work as output port. So to define that port as output, we will use these two lines. Then after that AD-con register. So AD-con register is FF. So why FF? You can see on the PIC microcontroller, each pin is connected with the some analog pin. Here also some analog pin. Then RE0 also connected with the analog pin, analog 5, 6. So to define this pin as a digital or analog functionality. So if the AD-con register is 0FF, that means whatever the pin used as an analog pin here, on here also, wherever RB0 analog. So all these pins should work as a digital input, not the analog input. So to work all the pin or to disable the analog input, we should use this line. Then after that ms delay, there is something delay function will be called here, and this is nothing but the simple for loop which iterates for 250 times, and it is nothing but the 256 millisecond delay. Then after that LCD command 0 cross 38. So why 0 cross 38? So once you open my LCD PIC 2, you will find the LCD command picture here. So double click on this picture, you will get some idea about command. So you can see once I open the picture here, you will find the command. Well, the first command is 38. So what is 38? Here you can see 38. 38 means 2 line LCD, 2 lines 5 by 7 matrix. So 2 line LCD means 16 by 2. We have 2 row in the LCD. That's why we are using 38 command. We have 2 row, 1 row and second row. That's why here 38. So to initialize that command. So before we send the data on the LCD, it is very important to configure that LCD as a 16 by 2. There is something like 2 row where when you start the message printing, then at which line it should start the message printing. So all this configuration, some basic configuration of LCD should do. So LCD, this command function will call LCD command. So you can see this is the function. So this function we already define here, void LCD command, and input is unsigned character value. So 1 bit data, 1 byte of data we are sending. So this is the 1 byte data, 38 byte, that is 38 number, that is means 1 byte of data. So on 1 byte of data we are sending here. Then that data is nothing but the value, and value we are giving with the LCD data. So first we have to send 38 number on this LCD. So once we send the 38 number on the LCD, how it LCD will understand it is a command or it is a data. So for that we have to select RS pin to the 0. So once you select RS pin to 0, that means this PIC microcontroller will send this RS pin to the 0 value here. So once here LCD get the 0 value, that means it is the command, not is the data. So what is the difference between the command and data? So data is nothing but your message. This is message. This is nothing but your data, and command means all these are the commands. Sorry, not this. All these are the commands. So to identify difference between the command and data, RS pin is used. So when RS is equal to 0, that means command is coming from the PIC microcontroller. Then after that, once the command sent, then we have to enable the pin, then we have to send one signal on the enable pin, then after some time again 0 signal, that is nothing but the one spike we have to send. Whenever we send the command or data, we have to first, whenever we send the command, we have to first send the data on the LCD, then RS pin to the 0, and spike we have to send on the enable pin. So this enable 0, then some delay, then some spike. So some spike is created, and in this way we successfully send one command on the LCD. So once you send the one command, then another command will be sent, then another third command, fourth command. So all these command will be sent, and same function will be iterated till all the command are completed. So I hope you understand the importance of command function. So once the init LCD command function will be completed, now the next function is send string. In the main function, we are talking about the main function only. So in the main function, next function is send string. So send string nothing but the one function which print this value whatever data on the string. So send string str. So only str means this first one. So first we have to print this one, then after some delay, then some command, then we have to print the send string 2. So second message we have to print. So what happen inside this send string function? So I will jump to here send string. You can see send string here. So once this function will be called, here you can see the input parameter for this function. In the C basic language, there is some basic, like whenever we want to send the data from one function to another, we need the input parameter. So input parameter is nothing but the character array. So already we have array here, and we are passing that array to this send string function, and this array str nothing but this one, and ultimately this array will get that value. So your first string is this one. This is my LCD 16 by 2. So this is first array. It is nothing but here it will come, and after that there is one variable. Why this variable is rendered, we will see later. So first we have to initialize that variable to the 0 value. Then array of I. In the C language basic, you know that the string end with the slash O. Whenever there is a string in the C, it's end with the slash O. So this one by one character, the H I S space, then I S. So all this one by one character is nothing but the 1 byte. So 1 byte we have to send one time at the 1 byte we have to send at one time to the LCD, because you can see in the code, in the this circuit diagram, only 1 byte of data we are able to possible to send on the LCD at one time, because there are only 8 pin on the LCD. And in this function you can see there are many bytes, but we can divide all these bytes into one byte, and we will send that byte. So how to divide that byte? By using this logic. So what here we will do, first array of I. So first I starting with 0, the array of 0 nothing but the T will be sent to LCD data. So this function again call LCD data. So LCD data coming here, and then what the value of here, value means what the value of this value variable, the T is coming. Why T? I told you, array of I nothing but array with 0, array of 0 index is T, then it will send to here, then T here come, it will come here, the value T is given to the L data. So L data nothing but the our data pin. Then now I told you already, if you want to send the data, we have to connect RS pin to the one signal, then again there is spike. So same logic, send data, RS pin to the one, enable spike, same logic. Then after that, after T we have to send the edge. So how to send the edge? This I will be increment automatically by 1. You can see I plus plus. So array of 1 nothing but the edge. So like this, one by one data will be sent. After D, this array of I is detected slash O. Slash O nothing but this string is finished. So no need to print the any data. So it will come out from this loop, and then our first string will be print on the LCD. Then after first string print on the LCD, there is some delay. Then LCD 60 command C0. What is C0? You can see, check here, C0 nothing but the force cursor to begin on the second line. So it will come uh, here on the second line, here it will come on the second row. So once come on the second row, we have to print the string 2. So how to print the string 2? Same logic, send string function will be called, this array will be passed, then one by one program video will be print on the LCD. So like this is the complete logic behind the LCD 16 by 2 project. I hope you understand the program. I hope you understand the uh, Proteus simulation also. Now next part is how to create the hex file. So once you open this program, you have to click on this button build all. So once you click on this build all button, you will see hex file is created at this path. So copy this path from here, copy this path from here, open your Proteus simulation, double click on this circuit, double click on this PIC Microcontroller, go to the folder. Once you go to the folder, paste that path, click on OK, paste that path here, file name, click on open, click on OK, then after that click on run button. So once you click on run button, you can see project start working. This is 16 by 2 LCD. Now we will see how you can use my ready-made simulation. So if you want my ready-made simulation, if you don't want to draw the circuit by yourself, then you require Proteus 8.9 software. So right click on this Proteus 8.9 software, click on run as administrator, then click on yes button, then go to the open project, then go to my downloaded folder link, downloaded folder. So whatever the folder I will provide on the code drive, that folder you can go there. So once you click on open, you will find the ready-made simulation. Then after that you have to load the hex file. So just copy the hex file path. I already told you how to create this hex file in the MPLab. So just copy this path and then double click on this pic, go to the folder, paste that path here, click on OK, click on OK, and after just click on this run button. So in this way you can use my ready-made simulation. So I hope you understand the complete idea behind this, how to connect LCD with PIC microcontroller. If you like my content, please click on like button, please subscribe my channel and please support me. Thanks for watching this video.